Okay, so here we have section 4.3, mixed and entire radicals. And our first radical rule, really. Remember we had all those exponent rules in grade 9? Well, we have a number of different radical rules as well. And here's our first one. The nth power of a times b is equal to the nth power of a times the nth power of b. What does that mean? Well, if I had, say for example, this, the square root of 20, which is also equal to the square root of 4 times 5, I could also rewrite that as the square root of 4 times the square root of 5. Now remember that because it's square root, I technically don't need to write the 2 there. The 2 is the only one that we never have to write there. Cube root, fourth root, fifth root, anything else we normally do. But just for simplicity and example's sake, I decided to write it in there. So now I can have, if I look at the square root of, I can't use red, square root of 4, well, what's the square root of 4? Well, the square root of 4 is 2. The square root of 5 doesn't simplify anymore. It gives us an ugly decimal number, so I can leave that as the square root of 5. Or more simply written, I wouldn't even write the multiplication in there. I would just write 2 root 5. So that's how we use this rule to help us what's called simplify radicals. This is a mixed radical. This is a mixed radical because it has a whole number and a radical. This way over here, where we started, well, this is an entire radical. Because there is no whole number component to it. It's just one big radical number. This is similar to thinking about fractions, in which, well, when we had the fraction 3 over 2, that's called an improper or whole fraction, and we could also change this to a mixed number, 1 and 1/2. So mixed number, whole fraction, is similar to entire radical, mixed radical. So we use this rule here, nth power of a times b is equal to the nth power of a times the nth power of b to simplify radicals. When simplifying radicals, what we do is we use our prime factorization from last chapter. Remember that? We rewrite our number using its prime factors, and then we look for factors in groups of whatever that index number is of the radical. Remember, the index number is that number written outside the radical sign. Square root, we never write it. So here the index is a 2. We just never write it. Here the index is a 2. We never write it. And here our index is 3. So we look for, in this case, groups of 2 or groups of 3 for these examples. And let's just work through the first one. So here we're asked to simplify the square root of 4. I know it's the square root of 4. There's no number there, but again, because I did just erase it, I know that there's a little square root there. So my first step is I break down this 4 into its prime factors, which I know are 2 and 2. Put it all under my radical sign. Now, because it's the square root, I look for groups of 2. Well, here is one single group of 2. This single group of 2 comes outside the radical sign. Excuse me. Comes outside the radical sign, giving me 1, 2. It's a single group of 2. And if I had anything left over, I would then write my radical sign with whatever else is left over. Well, in this case, there's nothing there. So my answer is just 2, simplified. And of course, we know that the square root of 4 is 2. Let's look at the second example. Square root of 80. Well, this is what the original example looks like. Root 80. I know that there is a little 2 there. I just never write it. It's the square root of 2. My first step, though, is I still break this down using prime factorization, which is 2 and 40, which is 2 and 20, which is 2 and 10, which is 2 and 5. So I know that my prime factorization of 80 is 2 times 2 times 2 times 2 times 5. 1, 2, 3, 4, and a 5. This is all under my root sign, and in this case I know it's a square root. Square root. Now, square root, so I'm looking for groups of 2. Here's a group of 2. Here's a group of 2. This 2 comes out. This 2 comes out. I multiply the 2 together. I'll do that in a moment. This 5, there is no match to it. There's no pair, so it's left over. It stays inside the radical sign as a 5. And, well, this is square root, so there's a 2 here. I just never really have to write it. Now, one step more to simplify this. I just simply go 2 times 2, which is 4. I write down my root 5. So here is our mixed radical for the square root of 80. Okay. And our last one here, the cube root of 144. So I'm going to do this one, and then I'll give you a break, and I'll give you a chance to do the examples that follow, and then I'll pick the video up going through those examples really quickly. Cube root of 144. First step, prime factorize 144, which is 2 times 72, which is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 and 3. 3 times 3. Write out my prime factorization while I'm dealing with the cube root of 2 times 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 2, 1, 2, 3, 4, times 3 times 3. And because I have the cube root this time, I look for groups of 3. Well, here's one group of 3. That's a 2. That comes out as a 2. And there's no other groups of 3. So I'm left with 2 times 3, or 2 times 3 times 3. This stays inside my radical sign. 2 times 3 times 3. Now, one thing to remember, biggest common mistake here is forgetting to write in the root, the index. If your index is not a 2, it has to be there. Otherwise, you've changed the question. If I no longer write that 3 in there, well, I'm no longer finding the cube root like the question started. Okay, so always make sure you write that index in. The only time you don't have to write it is when the index is a 2 and you're just finding the square root. So now, last part of this question, I simplify this a little bit. My 2 stays the same, and I just multiply back that the radicand, the information inside the radical sign. 2 times 3 times 3, well, 3 times 3 is 9, times 2 is 18. So 2 cubed root 18, or sorry, yeah, 2 cube root 18 is our mixed radical for the cube root of 144. I will give you a moment. You can start the next video when you're ready. The next video will quickly go through the examples that follow here, writing radicals in simplest form, or mixed radicals, the cube root of 40, and the fourth root of 162.